Math likes you. That's why math will not leave you because till your last breath. You don't like math, but math like you. Okay, nice. Fine, fine. So we are good to go now. We can start our session. Just a second. I'm just changing my network setting, guys. Fine. Just give me one moment. I'll start. All right, so let's get started. Fine. Okay. Full form of maths. मेरी आत्मा तुम्हें हमेशा सताएगी. Yes, last breath तक सताएगी. Yes, good afternoon, everyone. So we can start now. I'm going to start the recording, then I'll start sharing my screen. Just a second, let me start sharing my screen first. I hope my screen is visible to everyone. Let me just start the recordings.
Recording in progress.
Fine. So in morning session, we started with clustering, and we discussed about one clustering algorithm that was K-means, and I hope everything is clear till here. We are going to see the same similar type of data set again to be applied with different algorithms. So here we are going to train different model, like the model of DV scan algorithm on the same data set, and we are going to see, are we getting better result or it's not. All right. So I'm repeating again. So DB scan stands for density based spatial clustering of application with noise. This particular clustering algorithm was proposed by Martin Ister, Hans Peter George, and Zoe Zhu in 1996, long ago. Like 30-year-old algorithm we're talking about, but still it's there in industry. It is still getting used. Okay, so clustering we all know. Now, why we need density-based clustering algorithm like DBSCAN when we already have K-means? Now, the result that you can see over here itself. Results are clear. Sometimes the data points result in this way. The result of the data point is going to be in this way, where you have density for a particular class of the data. Here you can see this blue circle, basically it is a different cluster, and this orange circle is different cluster. So it is creating the cluster based on density, wherever the data points are densely packed over there. But here in K-means, as K-means is a centroid based algorithm, so it is working on centroid. So centroid could be anywhere, and whatever the data points are near to the centroid, that will be taken in that particular cluster. Now the thing is that this clustering is not not well defined over here. It is not what we can say, it is not good. On the other hand, if you are going to have the clustering like this, Now DB scan is going to have disadvantage over here when the whole data points are closely packed. So if I'm going to talk about density, it will take the entire data set. It will take the entire data set. So here K-means is going to work. Now when you have the clear separation between the clusters, if you have already plotted the data and you can see there is a clear separation between the cluster, that time you can blindly go with DB scan because you don't need to give the number of clusters that you want to create. In K-means we have to give how many clusters you want, but in DB scan we don't need to give. What do we need to give in DB scan? We need two things to give, that is E, value of E, that is epsilon distance, and minimum points. Minimum points, how many minimum points is going to be taken. Now, if I'm going to discuss about this thing in the same, let me just put it over here in the picture form. I hope you are enjoying this pictorial view better than more than PPT, right? Okay, so we'll be starting with DB scan over here. All right, so we are going with density. Now let's suppose we are having the data points over here. Some data points are over here. Some data points we have here and here. Now there are a few concepts over here. The first one is epsilon distance. Let's say epsilon distance I'm taking 3. Then minimum points. Minimum points, let's say I'm taking 4. Okay, it could be anything. Epsilon distance could be 5 also, and minimum point we can also take 3. Let's say I'm taking this thing. Now there are few concepts over here. First of all, we have core point. Then we have border point, and lastly we have noise. Now let's say we start our journey from here. So from here we'll try to calculate the epsilon distance. Now let's say if this is the data point, here I'm going to take the epsilon distance. So what I want, minimum 3. Let's say epsilon distance I have taken this much. Okay, it could be any value. Okay, so here in this epsilon distance, if I'm taking this epsilon distance, here in this epsilon distance I am able to take these 3 data points, right? I'm able to take these 3 data points. Now the next part, this particular point that I have taken over here, this particular point, this point is going to be considered as, let me change the color for better view. Okay, this particular point is going to be known as core point. And this point from where we are not going beyond, so this point and this point, these 2 points are going to be known as, let's say, border point. And from here, let's say I'm again going to calculate the epsilon distance. Okay, and in that epsilon distance I will try to find it. Do we have few more? So again we find out there are 2 more, 3 more. Again, let's say if I have taken this one, again we will go like this, and this chain will goes on and on until unless it is finding the data points over here that is satisfying in epsilon distance. In the epsilon distance 5, we have minimum 3 data point, and those data points, let's say this data point is not getting selected, this is going to be considered as noise. I'm repeating the things again. Okay, I have seen like Chirag is asking repeat. So what I am saying, let's say this is the core point. we have taken two parameters. In epsilon distance phi, we need 3 minimum points. So epsilon distance here we will be taking a radius, and in this radius we will try to find out, do we have 3 minimum points. So here we can see we have 3 minimum points. More than 3 is also fine. So the point that I have taken, this point is going to be considered as core point first of all. Core point, right? Others are going to be border point. And from one of the border point, we'll try to go for one more epsilon distance to find out, do we have the data points over there. It can go in this direction, then it can go in this direction, until and unless it is trying to get all the data points, if it is there. And if a data point is not getting selected, let's say this data point is not getting selected anywhere, this data point is going to be noise. This noise is not a part of any cluster. So here we have two clusters. Let's say this is one cluster and this is two clusters, and based on density we have created. Okay, fine guys, I hope it is clear how basically DBSCAN works. And the same thing I have added over here. Core, border and noise, and all the things are over there, border point and all. So this is how density is going to be created. Right? So this particular GIF will help you to understand a lot about DBSCAN. This is how you can see, based on the epsilon distance and minimum data point, the clustering is going on and on until unless it is not is going to calculate till the next end. If one cluster is over, it will try to find another density. If another density is over, it will try to find another density. So this is how it works. So we have only two things over here, that is minimum point. So as a thumb rule, you can see like minimum points, basically the number of dimensions, like number of points you want. E is nothing but the epsilon distance. So it can be chosen as using k distance on the graph. Okay, fine. And the distance functions over here that is getting used, the choice of distance function is tightly linked to the choice of E. Okay, what exactly you are using. Fine. So here what we are going to do, we are going to apply it again on the same data set. I'm just applying it on the same data set. Okay, file not found. I think I have to connect my drive first of all. I need to connect my drive. I think it's connected. It's connecting. Done. It's connected. Now I can run this code. So I'll get the data set. Yes. Here we go. Now I hope you remember what we have done here in this file, like a few of the changes we have done in the data set, within the data set. That changes we are going to repeat over here in this particular file. And what is going to be the changes, like taking the unique elements from horsepower. In horsepower, we are going to replace this particular value to the median, and we will be converting the horsepower into float type, and finally we'll be getting the horsepower as well. Once it is done, we are going to take the values. So basically dot values is the attribute that will change your data frame into a NumPy array. What type of array? NumPy array. Now here pandas and NumPy, they are interrelated. Pandas has been created on the top of NumPy. So this thing we have to keep in mind. Pandas has been created on the top of NumPy. So dot values, basically it gives you nothing but a NumPy array. So DBSCAN, the algorithm that we are having, what does it need? It needs nothing but one array. So this array we are going to give to the model itself, and before giving it to the model, we are going to simply plot it over here. So this is the distribution that we can see. If what we have taken at first, I think I have taken mileage, right? Mileage is less. When the mileage is less, horsepower is more. When the mileage is more, horsepower is less. And in between, you can see like there are some common data points, medium range like sedan and all. Now here, we'll try to do few things over here. Let's say I'm starting with epsilon distance 6. Now, when you are going to import DBScan is also going to be imported from the same library, scikit-learn.clusters. So here we have imported DBScan, and we are going to create the model here. And once you are going to create the model from this class DBScan, you have to mention these parameters. Epsilon 0.6, let's say, mean sample, let's say 5. So 5 data points we want to take. Let's run this. Model got created. Now we'll ask the model to fit with DF1, that is a data set that we have, and we'll ask the model to give the labels. Now labels that you are going to find here, you can see, so basically here it starts from -1, 0, 2, like that it will go. So what we can see, we have -1 a lot, 0 and 1 very few. Let's see what are the labels we have. 3 labels we have. All right, when we see the count, so count goes like this. -1 is more and these zeros are very less. Now if you are going to see this thing here on the graph, so the whole data points has been selected as only single cluster. That is not good. So here DBScan is not working well. So what you can do, you can try changing the parameters over here. Let's say I can put 0.5. Here I can put 6. Like this. We'll train it again. And we'll see the... Now, when I put 6, only 2 classes has been created. Again, -1 is... Again, it will not be the good thing. So basically, DBScan is not working well on this type of data set that we are having. Okay, it is not working well. So you can just go beyond, you can check it again and again. Now, one thing we can do, we can also scale the data. So we'll try to scale the data. Maybe data is not in the proper scale, so that's why we are getting this type of things. So let's perform the standard scale. Basically, standard scaler is going to standardize the data. It will put it in the this particular formula get applied. So x minus u by s. So x is nothing but the data point, u is nothing but the mean, the average of the data, average of the particular training samples, and s is nothing but the standard deviation. Yes, z score. So here we have scaled the data. We got it stored in DF1, and this time we are creating the model again. We are taking it over here, and this time we'll ask for give the labels. And do we get right number of labels? Got, but again, things are not doing in the proper way. You can change the numbers over here to 0.6. I'm taking 5. Okay, again we are getting this type of result. So DBScan is not going to work well over here. Just to show you how DBScan basically work well, I'm just going to open a new file. Okay, I'm just did I share this file with you guys? No, right? I'm sharing this file. Just a second. I'll share this file. Better you download and keep it with you, or you can save it in your drive. How you will save it in your drive? Yes, I have shared it, the viewer link. You can click on file, and here you will get this option, save a copy in drive. Better to save a copy in drive, or if you want to download and use it locally, you can download it. Dataset is same, the same dataset I'm using. Now I'm going to open a new notebook, not new notebook, other notebook. Yeah. Fine. So here what we'll try to do, we'll try to create random data points and we'll try to see how well DBSCAN is working. As of now, let's say we don't have that type of data that we can check for DBSCAN, but you will find on Kaggle, you can find on AI course website, you will be getting. Before moving ahead, I just wanted to share this file also with you, that is DBSCAN demo. Copied the link and I have pasted it here in the chat. All right, I hope all of you have got it. Fine. So here, let me do one thing. Let me clear all the output so that we can start from the scratch. Here we are going to import all the important libraries over here, that is NumPy, Pandas, Matplotlib to plot. From scikit-learn preprocessing, we are using standard scalar. Then scikit-learn.cluster, we are using DBSCAN, and one more thing, that is makeblobs. So makeblobs basically we use to create the random data points with random values. So here what we are doing, we are taking x and we are taking underscore. In the place of underscore, you can take y, whatever you want. Make blob n samples 3. That means create 3 samples. And blob means what? Basically, you will be having separate groups of 4 separate groups of clusters, like data points. Center form is what? 4 centers will be there. 4 different clusters will be created. Cluster standard deviation 1 by 2, random state 42. Okay, randomly 42 data points will be taken at a time. Done. We have created. Now on X you will find this random data points created, and in this underscore what you will get? The labels 0, 1, 2, 3. These are the labels. Now here, before moving ahead, what we'll do, we are going to transform this data. So transform this data means what? We are going to scale this. We will be applying standard scalar. So scalar dot fit transform x. We will get the scaled x over here. All right. Now let's come over here with DBSCAN. So we are coming back to the classification, but we are not doing the classification right now. We are trying to understand what dimensionality reduction, what actually PCA is all about, how does it work. Okay, this type of things. Now you can see like statistical summary, radius. The first column is radius. It ranges from here to here. Texture, area. So you can see all these static features. You are having the range, how it is going. And this data set is also very old. It was there in 1995. And you can also read about more about this column. So this is the toy data set, and you can also use some other data set also that you can see here. Real world data sets are also there, other data set that you can use. So basically we'll be using this particular data set. Okay, there are more data set over here. Diabetes data set is also very famous. As of now, what we are using this particular data set, is breast cancer data set. Fine. Let's come back. So here what we are going to do, we are going to load this particular data set over here. So actually when you are going to load this data set, and it is getting loaded from scikit-learn library, where we have this particular module called load breast cancer. So when you are going to create the object, this object is going to have, let me add one more cell and let me show you this object printed. So basically it is going to be a dictionary. dictionary, or you can say a sort of JSON, where you have keys, data. In this data, you have the array. Then you have target. Target means what? Whether the person is having cancer or not. 0 means normal, 1 means having cancer. So two things you can see over here. You have two keys, not only two keys, data and target. These are the two keys. If you will move ahead, you have one more key, target name. Target name is nothing but malignant and benign, right? Then what you will do, if you are going to go forward, you will find the features name. These are the features name. This basically are the features name, and there is one more. We are not able to view it right now. I think you will find it over here somewhere. I printed it, that's why it is not coming up. So basically, yeah, number of attributes, 30 numeric, and these are the features, right? So we got all these things together. These are the features name, and how many features are there? So feature names we have printed. We got the list. Breast cancer dot features name. So as it is a dictionary, so you can take out the keys over here. Length of the feature name is 30. That means 30 independent features we have. Now here, what we are doing, we are taking NumPy and we can see what is the target and what are the target names. How many unique target you have. Let's run this, and what we can see, two targets we have. Unique target is 0 and 1, and out of 569, 212 is for the normal person and 357 data points we have for the cancer patients, right? The patient having the cancer. Now there are multiple ways to train the model. So if I'm going to go simply over here, so first of all here we can see the distribution based on these two classes, malignant and benign. Benign means what? Normal. Sorry, benign means what? The person is having cancer, and red here it represents the person is not having cancer. So here what we are trying to do, we are trying to see the distribution of all the features, and we are able to see the distribution of the features because all the features are of float type. All the features have float data. So fine, we are able to look into the features and we can see the distribution. And one thing you can clearly say, if a person is having cancer, you can see this particular values are less as compared to the mean radius is less compared to this particular value for the normal person, and almost it is there in all, right? So better to see the distribution, right? And moving ahead, what we are doing, we are creating a data frame over here. From the given dictionary breast cancer dot data, we are creating the data frame. We are giving it the name to the columns, that is feature names, to this data frame, right? And we are adding one extra column that is not extra. Basically it is going to have the diagnosis, the name diagnosis, and diagnosis is going to have 0 or 1. 0 means person is normal, 1 means the person is having cancer. And by default you will be able to see first 5 and bottom 5 rows, and first 10 and last 10 columns, the features. Method 1. In method 1, what we are doing, simply we are taking a particular algorithm, let's say logistic regression. We are dividing it into X and Y, right? This is what we do, guys. I hope all of you remember all these things, simple things over here. So we are splitting the data into train and test, right? Test size, let's say we have kept 30%, shuffle and all, and we are creating one model, logistic regression, and once the model is trained, we are checking the score. So for the first time when we checked the score is 91%. The score is 91%. Fine, 91% is good. But as of now, what we are doing, we are training the model by giving all these features, all these 30 features. Now our goal is not only getting 91% or 92% on get satisfied. Our goal is to get more accuracy, more accurate model, more and more accurate model. So we are not going to stop at any time. Let's suppose you have got 92% or 85%, you just got to stop. Okay, I have got a good accuracy. You have to check. Can you get better? Now, method one was like taking the entire independent columns, all the 30 independent columns, and train the model. We got 91% accuracy. Now, the second method is going to be train the model while reducing the features. Reducing the features means what? Here we are going to compare the correlationship of the data frame with the diagnosis column, and we are taking the absolute values, because the correlation, if you're going to see, correlation will be in uh, what we say, it will be in negative also. Let me show you. Before moving ahead, let me show you the correlation also. Here only I can add one line of code. So what we have, let's say dfcorr we have. Let me create one variable corr, and here I'm going to have df dot corr, and what actually we will be getting, guys, we'll be getting a correlation matrix. Okay, now here we are going to plot this. Do we have imported seaborn? No, seaborn is we have not imported. Here I'm going to show you, just a second. Mat.lib is imported. I'm going to import seaborn over here. Let me just
તાંજ હોય
import
હોવાનો
it
તો
over
તાંજ
here.
હોય છે ને દીકરા, મેં થોડી ઉઠાડ્યો હતો ને, અમે અહીં જમી લઈએ ને ત્યાં. અહીં તો જગ્યા છે ખુરચીમાં ને એ ટેબલ ને બધું લાવે
So
ને બેટા.
import seaborn. So seaborn is another visualization library. Seaborn was SNS, and what we'll be doing, this correlation matrix we have, we are going to put into heat map. So SNS dot heat map, we are going to create heat map, and inside heat map we will mention this matrix,
કાં લખેલું હોય ને કરવાનું એવું.
and we are going to pass one parameter called not equal to true. So correlation matrix is going to be a bit large over here. Okay, this is clumsy. We are not able to see all these things. Now what do we need to do? Can anyone give me suggestion what we need to do over here to fix it? Anyone? What can we do to fix it? So guys, we can mention the figure size. So lt dot figure, and here we are going to mention the figure size. I'm going to increase the figure size. Let's say 10 by 10. I'm giving 10 by 10. All right. Let's say lt dot so name error, plt is not defined. Okay, I need to define mat.lib also. Import mat.lib dot pyplot as plt. Fine. Now this will work. Here I'm just increasing the figure size. Okay, this figure size is also not working well. We can increase it. Let's say, let's keep 15 by 10. Is it good? Twenty by 15. I'm taking this 20 by 15. All right. So we can see this particular graph. Can we open it in new tab? I just opened this image in new tab, and just look at this image. Okay. Now here on the right hand side, 14 by 10. Okay. Thanks, Chirag. 14 by 10 will work. Okay. You can try, guys. Yes. So you can see on the right hand side we have a scale. The lighter it is, more correlated it is. The darker it is, less correlated it is. Now we have to keep both things in the mind. The most like negative relationship and the most positive relationship. What we can ignore, the least relationship. So you can see here we are having the correlation with this target feature. I'm talking about target feature. The first feature, mean radius, is correlated to diagnosis 73%. So minus 73, that is minus 0.73 means what? Negatively 73%. What does it mean? There are three types of relationship. Okay, so first one is positive relationship, positive correlationship. That means if X is growing, Y is also growing. Okay, let's talk about the ice cream cells. If the temperature is growing, ice cream cells will also grow. So they have what? Positive relationship. Positive relationship. And negative is going to be, let's say, if the temperature is growing, sales of sweaters will become low. Sales of jackets will become low. That is negative correlation. So this minus basically represents the negative correlation. We have one more type of relationship, that is no relationship. No relationship means what? If X is growing or changing, Y is same. That means there is no effect of Y on X. That is neutral. Neutral or no relationship. Yes, Chirag has mentioned in the group, sorry, in the chat, neutral, positive, and negative. Fine. Now we need to keep this negative relationship also. Now negative means what? If I'm going to take negative directly, so if I'm going to compare with a number, so negative will be also always considered as. Now to cope up with this problem, what we are doing, if you are going to see here, we are using a function called apps. So apps is going to convert, even if you're having minus 70, it will be taken as 70. It's just like mod of something. Let's say mod of minus 12. What it will be? 12. So apps basically work as mod. And we are sorting the values ascending equal to false so that we'll be getting the highest list. So we have got the relationship over here, relationship with the target feature, the highest one we are getting arranged over here. What we can do, let's say I want only the features those who are more than 60% correlated, or at least 60% correlated. So we are taking the features over here, df.corr. So we are having the features name over here, right? So where the correlation is greater than 0.6, and as this is a series, so this is nothing but the index. This is the index. So what we are doing, we are taking the index and we are going to convert into the list, and we are taking from the index 1. Why index 1? Because index 0 is diagnosis. We don't need this column because this is a target column. We need it from here. We need all the things till greater than 60. So only what you will get, only this much, right? More than 60, that means this much only. 0.6 means what? More than 60%. So yes, we have got till from worst concave points to worst concavity. Fine. Once it is done, we are going to calculate one more thing, that is going to be VIF. So basically it is getting used to check for multicollinearity. Multicollinearity means what? If a particular like if you are having more relationship between uh, independent features, if the particular two independent features are more correlated, that means you are having multicollinearity problem. So we are going to remove those features that exist exhibits multicollinearity. So this need to get removed. Now for that, what we are doing, we are creating a model over here to calculate the VIF. We'll see. So two things we are going to take, VIF and tolerance. So we will iterate over all the features. For all the features, if the particular feature is not equal to feature will be taking in X, we are going to assign two things over here in DF and Y, feature in Y and DF in X. We are going to apply linear regression over here and we will get the R2 score. Okay, we got the score over here. Now the tolerance is nothing but 1 minus taking the feature 1 minus R square, and VIF of the feature is nothing but 1 by tolerance of feature. It is going to return a data frame where you will be getting VIF and tolerance both. So this function is going to give you this thing. Fine, we got all these things. So our aim is going to remove the features that have VIF greater than 5. So we can iteratively call this particular function in the different features, and we can have a feature set that has all the VIF lesser than 5. So let's create it like this, and then we are going to train the model. We'll be training the model on only those features. So we get the reduced features over here. We reduce the features based on the functions that we have. And when we train the model, what we have got 84%. Now what happened, even though we are reducing the features based on the correlation or calculating the VIF or tolerance and all, we are not achieving the same accuracy. Accuracy is dropping over here, but our goal is to increase the accuracy, right? We want to increase the accuracy, but as of now what we can see, accuracy is getting dropped. Now here comes this particular function PCA to rescue. Okay, now before applying PCA, what we need to do, we need to scale the data. So a scaling technique that we are using over here is the same standard scaler. So standard scaler is going to scale the data. We will get the data over here in X scale. And here what we'll be doing, we are going to import PCA. So PCA we are going to import from scikit-learn.decomposition. Now what does decomposition means, guys? Decomposition means what? Breaking it down. Like if anything get decomposed, that means it get reduced. So decomposition here, it is not like like the real decomposition. Here we are trying to reduce. So we will be importing PCA, and here as of now the components we will be giving the n components, number of components. So let's say PCA here you want 5 components, so you can mention 5. So it will be giving you 5 components, and based on 5 components you can train the model. Here we are giving none, and we are asking the model to the PCA to fit the X scale data. We are not given Y. Here it will try to find out the important features. It will create the components. So this initializer of PCA class has a parameter called n component that we have seen. So an integer to indicate how many components you want to reduce the features. So you can mention over here. As of now we have given none. Now it could be a floating point number between 0 to 1. So it is going to return the number of components that it needed to capture the specified percentage of the variability in the data. For example, we can take, let's say, if you want to find the number of components that need to capture 85% of variability, we are talking about the variability, 85% of the variability, then you have to pass 0.85 number of components. Alright, so here what we are going to do, we are going to check variance percentage. So PCA dot explained variance ratio. So when we multiplied with 100, what we are getting, these are the percentage. Okay, we don't need to worry about like what exactly it is. Let's move ahead. Now what we need to do, how you're going to interpret the above out. So here what we can interpret from here, the first component alone, here if you are going to see the first component alone, So many components it has created. The first component alone, it is taking 44% of the variability. Second component 1.89, that means almost 19%. So it is capturing 19% of the variability. And this 30 components all together is capturing 100% variability. So we will be calculating the cum sum, that is cumulative variance of the cumulative sum of the variance. So this is how it is going to be: 44%, 60%, 72%, and so on. Now, what we want over here. So you can also plot it over here in this, the length of PCA of the variance ratio. If the component is not none, is none, else the component you are going to plot it over here like this. So what we are plotting it over here, we are plotting the range. First of all, on x-axis we are taking the range from 1 to components plus 1. If the component is 14, we'll be taking 15. On on y-axis, what we are having, explained variance percentage. So PCA explained variance ratio into 100 we are taking. So here you can see. So this particular plot will help you to visualize the number of components that you need to capture the various amount of variability in the data. Let's apply this thing. So let's say we want to apply for 85%. So we are doing it again. So we are taking PCA, the number of components. We want the variability till 85%. We'll fit it thus with the scale data. We can calculate the cum sum of the explains variance ratio and all. And after plotting it, we'll be getting this type of particular graph. Right? So we can also find out the feature that contributes to each component. Okay. So whatever the components has been created, it is nothing but it is taking some features together. Some features are glued together. So what are the components? So PCA components are nothing but these are the components. But if we talk about the name of this component, so here let's say we want to find out the top 4 most important features in each component. So each component will be having important features, the important features. So one component, let's say PCA1, PCA2, whatever you are creating. So PCA1 will be having multiple features. PCA2 will be having multiple features. We have to find out which is going to work well. Now here, let's say we want to look into all the components. So total, how many components we have got? So we have got total 6 components over here, and each component we are trying to find out 4 best or 4 most important features. These are the 4 most important features as find out by PCA. Alright. So once it is done, what we'll do, we'll transform all the 30 columns to these 6 principal components. What we are doing, we are taking the PCA and we are asking it to transform this X scale. Now what we have got, guys, initially we were having 30 features. Now we have 6 components, that is 6 features over here. Now we are going to create the pipeline. Why pipeline is important? Over here you will be getting, let's say, 30 data points again and again from the user is going to give you all the details, but the model that you are going to train is going to be trained on only these 6 features, right? Only on these 6 features. For that we need to create a pipeline. So here the pipeline will be importing from scikit-learn library. So scikit-learn.pipeline, we will be importing pipeline, and we are going to also use pre-processing and standard scaler, PCA for decomposition and all these things. So we have created a standard scaler PCA component with components, I think it was null. Model is logistic regression again, and here we are creating a pipeline, logistic regression model, the pipeline is going to be consisting of the components that you want. So what we want, first of all, is scaling technique. So it is going to be taken like this: 1, 2, 3. So here, first of all, in the pipeline, what is there? We have a scaling technique. So whatever the input the user is going to give, first of all, it will get scaled. Then PCA will get applied, and those things will get given to the model. So this is how we create pipeline. Pipeline is nothing but the workflow basically. So pipeline will get created over here. Once the pipeline is created, we can split the data, and this same pipeline we will be using to feed the model. Now we are directly passing X and Y. So this X, what will happen to this X? First of all, this X will get scaled with the standard scaler. PCA will get performed on that, and you will be having the model itself. Now you can see when you are going to run this, you will be getting what you have: standard scalar. For PCA you have n component 6, number of components 6. Regressor, you have logistic regressor. Not regression problem, we are in the classification problem. So once you have trained the model, here what you will find after applying PCA, your accuracy will be okay. We have taken 6 components, but all those 6 components has not taken all the columns. Now after applying PCA, we are able to get better accuracy. We got better accuracy. Making sense, guys? Is it clear till here? All right. Perfect. One more time. Okay, one more time. What's your name? Your name is very weird. So guys, whenever you're going to join any call, do change your name, right? Be professional. All right. Perfect. Let me just explain you in the simple way. Codes and all you have already seen that you will be going through it. I know. Let's come back to the just a second. Fine. Sir, using pipeline, we automate the model. Yes, pipeline, we create pipeline just to automate the things. Okay. We create pipeline to automate the things. Yes. Wherever you are going to see the pipeline concept, so you are not doing all the things manually. You have put all the things in particular one object, and that object is going to follow the instruction. Like part one, what is part one over here? Scaling. So first of all, scaling will get done. Part two is what? Applying the PCA on given on this particular components, whatever the components you have given. If it is 6, the 6 components it will get created. Then the model. You have trained the model. The model that you have trained is going to be trained on this one. So that's why even if when you're going to predict it, so for predictions also you need to pass the data. You need to pass the data in the similar way. First of all, the data need to get scaled. Then it could get passed through the PCA, and the model is going to predict on those components. It is not like that I have trained the model on the components that we have got from PCA, and we are giving the original data directly to the model to predict. The model will say no. Model will give you error, right? So 30 features we have. From the 30 features, we have compressed it to 6 features. So this is how dimension we have reduced, right? Now let me just repeat this particular concept again through the slides. All right. So dimensionality reduction, the particular topic that we're talking about, it comes under unsupervised learning. Here we are not talking about machine learning. This is the concept where, or the process you can say, where we try to decrease the number of features or the variable in the data set, so that models, training time, computation cost of the model, it is going to reduce. The noise will get reduced. So it is very important, and whenever you're going to work in the real-time data sets and all, this is required, because as of now you're getting 30 features, but there will be a time you will be getting 100 features, 150 features, all these things, right? So all the system. Fine. Moving ahead, let's see with this particular diagram, not this diagram, the next diagram. So here, what you can see, what exactly we are creating principal component, PC, principal component. So one component can be combination of more features. So each component is going to find out the important things from the features and is going to be work as a feature as of now. And simply we can create multiple components, and those components can be considered as a feature while training the model, whatever the features you want to use, right? So this was about dimensionality reduction. The next thing that we are going to discuss is going to be association rule. Now association rule, again, it comes in unsupervised learning only, and mostly if you are going to talk about an association rule, basically we try to associate something. Associate something means what? We try to understand the relationship, the co-relationship, or the patterns within the large data set, and it also define like how often the item occurred together in the transaction, or it express the implementation. Let me just explain this particular thing with a very simple example. I think that example you have already seen in school. This particular example, let's say, if this then do this. Okay, not exactly, Nirmal. Let's say we have one data set. In this data set we have three features. First one is bread, then we have butter, and we have milk. And I hope all of you have already seen this particular table in your school textbook. Let's say first customer came. Let's say A. They bought bread, butter, and milk. Yes, exactly. Market basket analysis. B came. They bought bread, butter, but not milk. C came. C bought bread, not butter, but milk. D came. They bought bread, neither butter nor milk. E came. E bought milk, butter, but not bread. F came. F brought milk, neither butter nor bread. Then G came. G bought what? Only bread, and bread, neither milk or bread. Right? So there could be multiple combinations over here. Now, what we are trying to understand from here, if a person is going to buy bread, if a particular person is going to buy a bread, let me change the color just a second. Oops, not like this. If a particular person is going to buy milk or bread, if a particular person is going to buy bread, what are the chances they can buy butter or milk? If a particular person is going to buy milk, what are the chances they can buy butter or they can buy milk? So here we talk about support, we talk about confidence. So these are the things, and support, confidence, I think all these things you have seen in your statistics chapter in your maths book. I think it is in class 10 if I'm not wrong. Anyone, do you want to correct me? Was this in the class 10 textbook or in ninth textbook, if you remember? So basically, all these things are getting used a lot. This is there. Where you're going to find all these things? You will be finding this thing online in recommendation engines. Basically, recommendation engines work on this principle on how basically they work. Now, whenever you are going to watch any movie, any song, anything that comes from a particle genre, right? Okay, class 10 probabilities chapter. Okay, that comes from particle genre. Let's say you are watching a movie, you are watching action movie, or you are watching horror movie, you're watching comedy. These are the different genre. Now whatever you see on your feed, it is totally depends on the genre, what type of genre movie I'm talking about. Let's say I'm talking about this platform Netflix. What you watch on Netflix, what you watch on Netflix, you watch only two things: either movies or you watch series, right? Don't say comedy night with Kapil, okay? It is also there on Netflix, but mostly we are opening Netflix to either watch movies or some series. And movies or series basically uh, comes from different genre, like yes, action, horror, comedy, and yes, science fiction, sci-fi movies, and so on, right? So multiple things will be there. Now let's say how Netflix is going to know that you're interested in watching action movies, that you're interested in watching horror movies, or you're interested in watching comedy or science fiction. Basically, they run on recommendation engine. Recommendation engines. Recommendation engines. So how does recommendation engine work? So recommendation engines basically works on the watch history or the search history, what you are watching, what you are searching. You can take the example of YouTube. What type of videos you watch on YouTube? What is coming on your feed in the recommendation? Now, if I'm watching Shinchan all the day, I will be getting Shinchan or something related to Shinchan. Yes, exactly. I'll come back to that thing, Nirmal. I'll come back to you. Yes, Prithvi, right? Based on the previous videos you have watched. Now tell me, if you're going to open YouTube in your father's phone, what type of videos you are going to see? What type of videos you are going to see? If you're going to open YouTube on your father's phone, education, information, yes, something related to news, spiritual, financial, okay, old songs, very good. So I'm getting the right answers over here because I see the same in my father's phones as well. So my father liked to watch, that debate shows. Six peoples are in a frame and they are fighting with each other. Yes, sports. cricket or highlight. Nowadays in YouTube, you can find a lot of videos where you are having the highlights of the last match or the match played a long ago. So it's there. Previously, people used to watch TV only for that. Now everything is there on YouTube. Okay, okay, Tarak Mehta ka Ulta Chashma, right, Krinal, AVP News. Fine. Okay, this is about your father. What you are going to find in your mother's phone? When you're going to open YouTube in your mother's phone, what you're going to find out? Okay, I use 3 YouTube account for multiple purposes. Very good. Recipe, cooking. I'm getting all these answers. Recipe, cooking, devotional, bhajan ke gaane, right? Different recipes. Yes, my mom also watch recipes, but that recipe will never come, true. She watches, but she ignores. She is not experimenting. I don't know it's happening in your house or not. Opera, soap, serials, right? And yes, Anupama, right? All these things. Now, how YouTube is able to show you all these things? Basically, whatever we do online, guys, whatever we do online, we are creating history. We are creating not history, we are creating cookies. And those cookies are getting used by all these platforms. Okay? And in YouTube, your cookies are nothing but your watch history only. You have created a watch history that you have watched Shinchan, 5 videos of Shinchan Lagatar, right? And when you're going to close YouTube, you will open it again, you will find that thing only. You are going to find Shinchan again, or you're going to find that Ogi and the cockroaches, those type of cartoons, right? So basically, here they want to give you a better user experience. Why a better user experience? No, it's very simple. If I am on a platform and if I'm getting a better user experience, I will stay longer on that platform. On YouTube, when I open YouTube, I'm able to find the videos that I'm likely to watch. So that I will stay, I will watch the videos again. In YouTube, you have shorts also, the similar type of shorts you will be getting, right? So you are going to stay longer on their platform. So the longer you will stay, the more ads you will see. And how they earn by showing you ads only, right? They generate the revenue by showing you the ads. The similar thing we can have on Instagram. Instagram's algorithms also work in the same way. Not only based on the watch history. Basically, it totally depends on how much time you are spending on a particular reel. Are you watching the reel again and again? That means you are interested in those type of reels. Now, let's say I am getting the reels. Nowadays, I am getting the reels on, let's say, like decorative item and all, right? I need to do some home interior work, and I was exploring the things. Nowadays, everywhere on YouTube, on Instagram, everywhere I'm getting something how to improve the interior, all these type of videos. So I watched one type of video. I stayed longer on that particular platform, and I was watching only those type of videos, and their algorithm understands, okay, this particular customer, this particular user is interested in this type of videos. Let's show this type of videos to them, right? Yes. Now let's talk about Instagram again. What type of reels you see? Now, if I am going to divide into boys and girls, and I am talking about the real thing, guys. So boys, 60% of the time, boys, they will be getting reels based on cricket, football, or something related to gaming. 60% of the time. 40% it's on them, like stand-up comedy and anything. Is it true? Anything related to sports? Yes, gym. Yes, if you are a gym person, you will be getting similar type of videos. Sports, anime, yes, this type of things will come. Exactly. Now, when it comes to girls, what do you see, girls? 60% of the times. Yes, you will be getting the cards on reels on cards and all. cars, bikes, modification. Boys will get all these things. Okay, what girls? Guys, you are responding on behalf of girls. I'm asking girls. I'm getting comments only from boys. Korean drama, BTS, all these things, makeup and all. Okay, if we talk about like the preference of girls, like it can depends on the age also, right? If you are a less than 20-year-old or you're more than 30-year-old, the preference will be different. But if I'm talking about that your age, right? All of you are in college. You may be around 20, 21 or 22, right? Now, in your age, most of the time, what exactly you are going to see, you people are more into dresses, right? What type of reels you see, that unboxing 250 rupees wala Meesho ka product, right? More, you will be getting more reels on dresses, more reels on, let's say, uh, yes, more reels on makeup, cosmetics, and all, and also grooming videos. Grooming videos, girls also watch most, right? How to design the things, the skincare, yes, skincare, and not only skincare. Girls are more into creativity. Creativity means what? Art and craft things. Is this girls? Do we have girls in the meeting? I can't see any any comment from a girls side. So girls are more into art and crafts, and they will be getting those type of reels, like DIY products and all, how to decorate the things. Cooking also, yes, cooking, painting, poetry, yes, all things are there. And like for 60% of the time you're getting this type of things, and 40% it's on you what type of person. Okay, why I'm saying what type of person you are, look, it's very simple thing. If you want to understand what type of person is your friend, what type of person is your friend, take his or her phone and start scrolling the reels. You will come to know. I'm not talking about that 60%. I'm talking about those 40%. Those 40% reflects you. And in YouTube recommendation also. Now let's suppose I am only watching, I have opened video on YouTube and I'm only watching, let's say, songs. That means I am more into songs. I don't do anything creative. If I'm getting mixed recommendation, that means on my YouTube you will find, yes, I'm also listening to songs. I'm also watching some videos related to latest tech and all, and I'm also looking into this recipe videos and all. On my YouTube video also, you in recommendation you will find recipe and all. Fine. So this is how recommendation engines work, and all these things are coming from. Okay. Thanks for the reminder, Krishna. Just a second, guys. I'm sharing the attendance link. Okay, I need to stop sharing the screen as of now. I'll be sharing the attendance link. Thanks for reminding. Okay, till then, people, you have any doubt, let me know in the chat if you have any doubt. No doubt. Is everything clear? Okay, I have shared attendance form, guys. I'm sharing it again in case few people will rejoin. You can mark the attendance now. Let's come back to the topic. We have seen damage reduction. Where were we here? Association rule. I think I have given you the context already. What exactly all these things are all about. Feedback form. Okay. Let me get the feedback form. Just a second, guys. I need to ask for the feedback form to others. Just a second. Just give me a minute. All right, feedback form. Got the feedback form. Attendance marked, very good. I will be sharing the forms again. Feedback form, yes, here it is. Okay, you can fill out the feedback form also. I'm sharing the attendance form again, guys, in case if you have missed. Okay, both I have said. Okay, trainee name says, you can select, no problem, you can select. I will ask them. Whatever you have, you can select. Well, my name is Pius, I think you can see on here, but if it is not there, no problem. Let me check. Let me just check. Uh, Wait for a minute. Okay, guys, I will be sharing it again if any changes is required. Otherwise, I'll let you. Okay, let it be. Okay, so some problem is coming from Hari. I am feeling external. Let me just a second, guys. Let me just go to the. Just a second.